So I'll introduce two variables here. The first one is the distance in kilometers for this fixed route, and also the scheduled time. And this is in hours, meaning the time it takes for this bus to go from the beginning to the end. So that's the T hours. And then I'm going to write these conditions, the two situations they've given us. The first one is that if it travels at 60 kilometers per hour, so that's the speed, it reached 3.5 hours later. So the total time it would take is T plus 3.5 hours, where T is the scheduled time. So that means that the distance, D, would be speed times the time taken. So that's our first equation. The second one comes from the scenario which says that it traveled 2/3 of its route, so 2/3 of D in kilometers, in 1/3 of its scheduled travel time, so 1/3 T hours. And the remaining part, which would be 1/3 of D, it traveled at 40 kilometers per hour and reached just on time. So that means this total is T hours. And that means for this portion, since this was 1/3, this would be 2/3 of the time, the scheduled time. So the condition here would be distance would be rate times time. So that's our second equation. And you'll see the 3 drops out. I get D is 80T. Here, if I distribute, I get that equation. I'm interested in T, so I equate these two because they're both D. Subtract the 60T, so I'll get 20T is 60 times 3.5 divided by 20, and then 3 times 3.5 is 10.5 hours. So the bus started at 9 a.m. Its scheduled time to travel that whole trip is 10.5 hours. So we add that to 9 a.m. So 3 hours would leave us to noon. We're left with 7.5 hours, which means it would reach there at 7:30 p.m. Choice A.